In question 10a, we have to find the quotient and remainder when x square is divided by 1 plus 4x square. So we'll write it as x square is divided by 4x square plus 1. So in the first step, we'll divide x square upon, we'll write it as 4 upon x square upon 4x square. This will cancel. So we'll get 1 upon 4 over here. 1 upon 4 will multiply by 4x square, and that would be equals to x square. 1 upon 4 into 1 would be plus 1 upon 4. We'll change the signs. So this will become plus, this will become minus, this will cancel. We'll get minus 1 upon 4, and we cannot divide it any further as there is no power of x, or that it is lower than the power of x over here. So the remainder would be equals to minus 1 upon 4, and the quotient would be equals to positive 1 upon 4. Now in part B, we have to find the exact value of x tan inverse of 2x dx. So we'll have to use integration by parts over here, and we know that the integration for, so let's say if we have the term, if we have it as 1 upon x square plus a square, when we integrate this, we get 1 upon a tan inverse of x upon a. So the integration of this term we know. So, and we cannot integrate tan inverse of 2x. So even though we use LATE and algebraic function has to be taken as u, but as we know the derivative of this function, tan inverse function, so we'll take this as u. So u would be taken as tan inverse of 2x. So the derivative of tan inverse of 2x. So now if we just relate it over here, we'll know that, so if we have tan inverse of 2x, the expression over here, or the derivative of tan inverse of 2x would be, so du would be equals to, so the value of a is 1 upon 2, as if there is a 1 upon 2 over here, it will come up in the numerator, and there is no 2 over here. So what we can do is, in this instance, let's say a was 1 upon 2, so this we should have added 2 over here. So what we can do is we can uh, divide both sides by 2, maybe, yeah. So if I divide both sides by 2 over here like this, and this side by 2 as well, so this 2 and 2 will cancel. So the derivative of tan inverse of 2x would become 1 upon 2 into 1 upon x square plus the value of a would be 1 upon 2. So we'll get x square plus 1 upon 2 whole squared. Now simplifying this first, because otherwise it will get a bit tricky. So we'll get du is equals to 1 upon 2 into 1 upon x square plus 1 upon 4. Taking the LCM in the denominator, we'll get 1 upon 2 into 1 upon 4x square plus 1 upon 4. This 4 will come up in the numerator. We will write it as 1 upon 2 into 4 upon, so 4 upon 4x squared plus 1. This will cancel out and we'll get 2 upon 4x squared plus 1. So this will be du. So du would be equals to 2 upon 4x squared plus 1. And v was x, so v will be d will be taken as x. So v would be x squared upon 2. Now applying integration by parts, what we'll get is, the formula is vu minus v du. So v is x square upon 2 into tan inverse of x, into u is tan inverse of 2x, minus v is x square upon 2 into du is 2 upon 4x squared plus 1 dx. This 2 and 2 cancels out. So we'll get, we'll leave the left hand, this term as it is. And now we have to integrate we have x squared upon 4x square plus 1. Now we'll use part A in this case. We divided these two functions and we got the quotient and remainder as 1 upon 4 and minus 1 upon 4. So we can write this expression as 1 upon 4 plus, and just for revision, so let's say if I divide 7 by 3, so we get 2 wholes 1 upon 3, or we can write it as 2 plus 1 upon 3. So I can write it as 1 plus minus 1 upon 4 divided by 4x square plus 1. So simplifying this, I will get 1 upon 4 minus 1 upon 4 into 4x square plus 1. All right, so we'll get this in place of that expression. So we'll have, in place of this expression, we can write it as, okay, we can write this term later on. So this will become minus, and with the integration sign, we'll get 1 upon 4 minus 1 upon, so this will become 1 upon 4 into 4x square plus 1. So 1 upon 4 into 4x square plus 1 dx. So we can take the 1 upon 4 common outside to make things easier. We'll get 1 minus 1 upon 4x square plus 1. That is the term we have to integrate now. Now again, for this 1 upon 4x squared plus 1, we can use the tan inverse integration. But for that, we need the x squared term with a coefficient of 1. So we can write this as, 1 upon, taking 4 common, we'll get x squared plus 1 upon 4. And then the next step, we can write it as 1 upon 4 into x squared plus 1 upon 2 whole squared. Now we have it in the expression where the value of a is 2. Sorry, the value of a is 1 upon 2, like over here. And that will be 1 upon a into tan inverse of x upon a. So integrating this side now, we'll get this is 1 upon 4 as it is. The integration of 1 is x minus, and this will be 1 divided by 1 upon 2. Not to forget, we still have the 1 upon 4 over here. Okay, it's getting a bit lengthy now, but anyways, so 1 upon 4 and the integration is 1 upon a. So a is 1 upon 2 into tan inverse of x upon a. So x upon 1 upon 2. We'll simplify it now. So this will cancel out with the 4. We'll get 1 upon 4 into x minus 1 upon 2 tan inverse of 2x. So this is the final integration, and this term before remains as it is, that is x square upon 2 tan inverse of 2x. And do we have to put the limits as well? Oh, wow. We have to put 0.5 and 0 as well. So we'll have to make some space over here. Now let's put in the limits. So the final expression, let's write down first. That is x square upon 2, and I hope I haven't forgotten this 1 upon 4 over here. So that was 1 upon, yeah, no, I have taken that into consideration. So that is x square upon 2 tan inverse of 2x minus, that will become minus plus 1 upon 8 tan inverse of 2x and minus 1 upon 4x. So this, there is no mistake so far, and now we can just simply plug in the limits. Obviously, we'll have to open the bracket first, so we can write it like this. Minus 1 upon 4x plus 1 upon 8 tan inverse of 2x. And now using our limits that are 0.5 and 0. So first substituting x equals to 0.5, we'll get 0.5 squared upon 2 tan inverse of 2 into 1 is 1 minus 1 upon 4 into 0.5 is 1 upon 2 plus 1 upon 8 tan inverse of 2 into half, that is again 1, and then subtracted from the lower limit, which is 0. So tan 0, 0, 0. So with the 0 limit, everything will cancel out and we'll have only this term remaining. Substituting this into our calculator, so zero point 0.5 squared is basically 1 upon 2 squared. That is equals to 1 upon so 1 upon 2 squared is 1 upon um 4, and 1 upon 4, this will become 1 upon 8 tan of 1 minus 1 upon 8 plus 1 upon 8 tan inverse, and I think there's an inverse over here as well. So yeah, that is tan inverse of 1, and this is also tan inverse of 1 over here as well. So simplifying this in the calculator, shift tan inverse, and we have to keep this in radian mode. So shift tan inverse of 1, that's pi upon 4. So that will become pi upon 32 minus 1 upon 8 plus pi upon 32. So 2 pi upon 32 will be written as pi upon 16. So the final answer will become pi upon 16 minus 1 upon 8. Now that was quite a lengthy one. And that can only be done in one attempt. If we have enough practice with these questions, at least you should have done 30 to 40 questions of similar type before the exam.